Hola everyone. So the other day I was doing this kata on Code Wars and I thought it would be kind of fun to just go through it and show you guys what doing a kata on Code Wars is like if you've never done one before. So if you guys aren't familiar, this website Code Wars, it's this website that's full of all these coding puzzles that you can do that allow you to sort of test yourself and see what you're capable of. They get the word kata from karate, so I actually have the Wikipedia here. So in martial arts, I said karate. I'm not sure if it's karate, but it's martial arts. It refers to a detailed choreographed pattern of martial arts movements made to be practiced alone. So that's the idea here. The idea is that you're practicing it alone to sort of test yourself and again, see what you're capable of. Katas are ranked on difficulty, actually, so we can see the ranks here. The ranks go from 8Q being the easiest to 1Q being the hardest. Your personal rank can go up higher than that. I'm assuming if you get like 1Q in all these different languages, you'll probably be going up into the 1 dan, 2 dan ranks. But again, that's also borrowed from martial arts. Again, I just wanted to show off what this website was because I think it's really cool. I'm not a software developer by any means, but I did do a little internship with a software factory for just a little bit to see what it was like. And we had this senior dev who he would have us all do a kata every single day before we even started coding anything. And it wouldn't be from Code Wars, they would be ones that he made himself. And so we would all start at the same time, we'd all have the same amount of time to do it. We would try to see who could do it the fastest or who could do it the cleverest. And if you couldn't finish it, he would have us go through and explain where we got hung up on. So I just thought it was a really cool practice. And again, I use these as basically my version of a Sudoku puzzle. So if you're not a software developer, if you're not a coder by trade, you can pick any language you want. Well, not any language, but they have quite a bit. Like for this one kata, they have all these available languages. And you don't have to be a programmer to get something out of this. So I just think it's fun to do. So on that note, I thought it would be fun to go through this little problem here. So maybe you've read it already. I'm going to read it real quick and then I'm going to explain it. I'll visualize it a little bit, so in case you don't understand what's going on, because it took me a little bit to understand this line here. But so we're given an array of positive or negative integers. So we're going to have to write a function that's going to take that as an input. They'll give us the input. It's going to be an array of positive and negative integers, and we're going to have to produce a sorted array, which they name P, of the form. So it's going to be an array of smaller arrays, and then within each smaller array we're going to have P, which is going to be a prime factor, and then the sum of all ij is just some random integer from our original array, of I, for which P is a prime factor of ij. Okay, P will be sorted by increasing order of the prime numbers. Okay, so what does that mean? So I'm just going to pull up Photoshop here and write this down. So as an example, so they give the example of they have an array of 12 and 15. So the first thing we're going to want to do is get the prime factorization of each, right? So the prime factorization of 12 is going to be 2 times 2 times 3, and the prime factorization of 15 is going to be 3 times 5. Okay? So the next thing we're going to want to do is we're going to want to get each unique prime. So we have one unique prime here, here, and here. So we got 2, 3, and 5. That's our set. And then our result is going to be an array of arrays. And the first thing in each array is going to be those primes that we found, but sorted from lowest to highest. So 2, 3, 5. And then the second thing in each mini array is going to be, so 2 goes into only 12 here. So 12 is what we're going to put down. But 3 goes into both 12 and 15 from our original array. So we're going to have to add those both together, and we're going to have to put 27 down here. And then finally, for the last one, 5 only goes into 15, so we'll put a 15 here, and this should be our final answer. All right, cool. And so, by the way, I've already gone through this, but I'm gonna do my best to try to go through it as if I was going through it the first time. Like, I wanna show you the mistakes I made along the way, so maybe you can either avoid them or know that it's normal to make mistakes. Also, if you wanna try this yourself first, I'm gonna put a link to it down in the description. So this is a 4Q one, so it's somewhere like in the middle difficulty here. So if you want to try one that's easier or harder, you can just make your own account or search for your own. Anyways, let's get this going. All right, so here we have a summary of the problem again on the left. We can also have the output when we run our tests here, and this is where we actually do our code. And these are some sample tests, so we can see some of the tests right off the bat that they're giving us. So they're giving us 12 and 15, and then this array here, and then this is what they expect to get, and then this is what they expect to get from that one. Okay, so my senior dev, he always advised that we figure out what we want to do, like what our game plan is, before we even put down a single line of code. I mean, that's pretty good advice. So what would our game plan be here? How would we actually solve this problem? Well, I mean, I see this as like a 3-step problem, right? So the first thing we want to do is we want to get the prime factorization of each number from our original array. After we get the prime factorization, we need to find all the unique primes. After we find all the unique primes, we need to cross-reference our primes that we found with our original list and start doing all the adding and reducing and such. Okay, cool. So this is our game plan. Let's do it. Number one, starting off number one, what do we want to do here? So my first step is to find the prime factorization of each number. But if I'm going to do that, I'm going to need to find a way to tell if something is prime or not. So I guess that's where I would start. That's where I did start. I would start with a function that tells me, is this number prime or not? So I'm going to make a function is prime. It's going to take in a number. I'll just call that n, and it's going to spit out a boolean. It's going to spit out true or false, so whether or not the number is prime or not. Okay, so how do we know that a number is prime? Well, we know that any number that is even is definitely not prime unless it's the number 2. So I'm actually going to put that first. I'm actually going to put if n is equal to 2, I'm just going to return true, because 2 is prime. But if the number is even besides the number 2, well, then we know it's not prime for sure. So we could just put if n modulus 2, which means divided by 2, and then give me back the remainder. If that remainder is equal to 0, we return false. Easy. And then so then we have a number that's not 2 and it's not even. We're just gonna have to check the number all the way from, we'll start from 3 up until we get to that number and see if any number cleanly divided into it. And if it didn't, well, then we know our number is prime. And if a number manages to cleanly divide into it, well, we know it's not prime. So I'm just gonna make a for loop here. So I'll just use a generic I, and we'll set that equals to 3, and we'll go up until I is less than or equal to we don't actually need to go all the way to the number. We can actually just go through up to the square root of the number, because going anywhere past that is kind of redundant. So we're just gonna do math.square root of n, the number we're given. And then we're gonna go up, we're gonna check every odd number. So we're just gonna go I plus equal 2 instead of the usual I plus plus. And then we're gonna say if our number divided by the iterator, it cleanly divides into it, we're going to return false. So if any of these numbers divided by our original number gives us no remainder, we know this number is not prime. And then finally, if none of these things check out, then we know the number is prime, so we can just return true. Cool. And I like to just add in some console logs to make sure that this thing is working correctly. So I'm just going to do something like console.log 70 should return false, console.log 7 should return true. Let's just test this real quick. I just console logged those numbers, which was crazy. I meant to console log the result from this here, tossing our numbers into our function. There we go. And there we go. False and true. Perfect. Okay, we can move on. All right, so now that we have a way to check if a number is prime, we need to go actually find that prime factorization. Now let's do that. So I'll make another function. I'll call it get prime factorization. So it's going to take in a number and it's going to return to me the prime factorization in the form of an array. So it's going to return a number array. But how do we find the prime factorization of a number? Generally, the way you want to do it, or an easy way to do it, is just so if we have a number, we'll take like 70, for example. You just need to find 2 factors of it, and then you'll break that down into like a tree. So you'll do something like here is 5, and this is 14, right? Yes. All right, so we have 5 and 14. So 5 is prime already, so we're at the end of this branch, and then we just continue doing this until we only end up with prime numbers. So let's do 2 and 7, and what do you know, these are both prime, so our final prime factorization is 5 times 2 times 7. And whenever I have a sort of this kind of pattern, like a tree pattern like this, where I don't know how many times I'm going to have to go through it, I like to do a recursive function just because I find it easy to understand. That might not necessarily always be the most efficient way to do something. And as a heads up, for some of the later katas, one of the biggest differences is that they'll usually require you to be some amount of efficient. So if you have too many like loops within loops, your code is going, even if your code could technically work given enough time and enough power, it'll probably just time out before it actually solves the problem. And so you're going to actually have to solve the kata in a smart way. With the earlier katas, it's not usually as big of a deal. And actually, in fact, we should check to see what kind of numbers we're getting before we move on here. So like, let's just make sure that we're not getting anything too big. I'm going to hit attempt to see what kind of numbers we're getting. I'm looking to see if we get like numbers in the hundreds of thousands or something. And it looks like the highest number I'm getting is like, I see 2,500 here. Yeah, I'm not really seeing any big, let me console log what they're giving us here just to, so list is what they're giving us here. So let me just, whoops, I hit test, I meant to hit attempt. I'm seeing as high as, yeah, these are pretty low numbers, so I don't think that we're going to be dealing with any big numbers, so it should be fine to use a recursive function. And so if you don't know how a recursive function works, it's a function that calls itself in the middle of it resolving. So here's the way I'm going to imagine it. So I'm going to make a function. I'll just name it, or I name my function prime factorization. So I'm just going to call this function pf. And it's going to take in a number and it's going to return a result. And whenever we do a recursive function, I think it's easy to put the result that you're going to get as one of the parameters so that your function can share that. It can share that data in between function calls. You'll see what I mean in a second, I think. But so I'm just going to put the result here. And so every recursive function needs a base case. It needs a reason to exit in the first place. And so our base case is going to be if the number is already prime, something like that. All right, so if the number is already prime. So let's say we pass in 5, for example. So we pass in 5 into our function here. And so 5 would be this. We're going to have a resulting array that's just going to be empty initially. And all I wanted to do is if the number is already prime, I just wanted to toss this number into our result array, and then I just wanted to spit that out. So this should be the prime factorization of 5 if we pass in 5. Okay, cool, but what if the number is not prime? Well, if the number is not prime, well then I needed to, so let's take a number like, I don't know, 20 for example. Yeah, so I'm gonna pass 20 into our function here. Again, we're gonna start with the empty array. And what I'm gonna need it to do in this case is I'm going to need it to find a factor of 20. So let's just say 2, for example. It's going to pull out 2 and then it's gonna toss it into this array. And then I need this function to call itself again, but this time with everything updated. So I needed to call, so it's gonna pass in 20 divided by 2, which is 10. And then it's gonna start with this array already having something in it from the previous call. It's gonna start with 2. And then it's just gonna do it again. I'm actually just gonna circle like this way here to make this easy. But once again, I mean, it can just use 2 again. So we could just pass in 2. And then we got 5 here. And now our array begins with 2 elements in it on this function call. But now here we've reached our base case. So this is our base case from up here, right? This number is now prime. So now on the last function call, it should just pass 5 into here and spit out our prime factorization, okay? Hopefully that makes sense. So let's get to coding that. So I'm actually gonna put the result here. Again, like I said, it's gonna be my returned number array, and by default, it's just gonna be empty. And then I'm gonna have to check if the number is prime or not. So if is prime number. And it was at this point that I realized that I did something slightly inefficiently, or at least there was something that I could do to make this a little more succinct here. Because I'm checking now to see if the number is prime, but if the number, it turns out, is not prime, I'm still gonna have to go in and check and find one of those factors for that number, which might be a little redundant because I already have a function that basically does that, except this function only just returns whether or not the number is prime or not, but it doesn't return what the actual factor it was that it found. But I could just have it do that instead. I could just have this return the factor that I'm looking for. So if I'm changing the functionality of this function, I'm going to change the name of it. So I'm just gonna rename this to get next factor, or maybe I should just get factor. And then I'm just going to, so this is going to return instead a number, and that number is going to be the factor that I want to return. So if the number is prime, I guess I should just return the number 1. So everywhere it says true here, I'm just going to return 1. And if the number is not prime, I'm going to return the factor that it found. So if the number is even, I could just return 2. And if the number is odd, I could go through this loop and return whatever iterator made this condition true. So I'm just going to return I, and that should work. So once again, so let me block this out again. Let me put it in our console logs again. All right, so I have 70, 17, and 35 here. Let's see what we get. Just going to hit the test. A factor of 70 is 2, 17 is prime, so it gave us 1, and a factor of 35 is 5. So that seems to work out just fine. Okay, let's continue our function here. So if the get factor of the number that we passed in, if that is equal to 1, meaning our number is already prime, then I want it to just return this resulting array, but with our number added in. So I'm just going to take whatever our resulting array is. The spread operator says, hey, whatever elements are in this array, just put them in a new array and give that back to me. But I can also still use a comma here, so I can say at the end of it also add in the number that we passed in. So like we already said, if the number is 5, it'll put 5 in here, find that that will give us back 1, which means it's prime, and then it'll just return to us an array with the number 5. If this array has more stuff in it already, it'll return us that whole array plus the number 5 at the end. Okay, so that's our base case, and then we got to do what happens if the number is not prime. So if the number is not prime, we should return. So we need to return this exact same function. We need to loop through it again. Our number is now going to be our number divided by whatever our factor was, which our factor is in here, get factor. I'm going to have to use this. So I could do this, but now I'm making this function call twice when I don't really need to. I'm just going to make another variable, and I'm going to replace this with factor. I'm going to replace this one with factor. Cool, cool, cool. And so we're going to call this again with this number divided by our factor. And then our resulting array is going to have that factor in it. So we're going to have to pass in whatever the array already is plus our factor. And that should give us our prime factorization. So let us test this out real quick. Let's do 12 and 15 since we already know what those are going to be. 2, 2, 3, 3, 5. Perfect. All right. So now we just need to get the prime factors of all of our numbers. Real quick, I'm just going to add some comments here to make sure I understand what these do, or make sure whoever is reading this understands what it does. All right, so our next step is going to be getting all those prime factorizations from our original array. And as a heads up, you could do this all in like one big line. You could just do like a chain on some dot maps and dot flats and dot filters or whatever you want to do to make one really cool long line that just does this all in one go. The problem is if you want to go troubleshooting your stuff afterward, it can get a little annoying trying to piece together like what part of the chain is breaking something. So for example, here I'll just show you what I had here. I will show you this at the end again. So I basically had this long line that makes our prime factors in one go, but troubleshooting this was annoying. So what I'm going to do is I'm just going to do everything one step at a time, put everything in its own variable, and then at the very end, we'll refactor it. All right, so let's just do that. So let's say, so first thing we want is our prime factorizations, right? So let prime factorizations, it's gonna be an array of numbers, and let us set that equal to, so we want our original list, which was LST, and we want to map over it. The problem used the letter I for the individual elements, so I'm just going to use that. And then we want to call our get prime factorization function on that. So let's just do that. So if you don't know what .map is what they call a higher order function. It's like my favorite functions in JavaScript in these katas because I think they're the most fun to use. And it just says that take this array. I'm going to pass in an anonymous function here. And I want you to apply this function to each element within the array and then give me a new array back. So for example, I'm just going to console.log this. My original list before, and then this is going to be my prime factorization afterward. Let's hit test. So this was our original list, and now here's our new list. So 12 has been replaced with this array, and 15 has been replaced with this array. Cool. Now the next thing we need to do is get all the unique primes, but right now the way I have it, it's going to be annoying to like have to dig in. I have to dig into this array and then dig into these numbers and compare them to this array and this number. Like it gets annoying because when you have an array within an array and you're trying to check everything, you're going to have to use at least like one loop within another loop. It's going to get annoying to me. Luckily, I know of a way to kind of shortcut it, and that is this function here from JavaScript. So let's just test that out real quick. Dot flat here should just flatten it. Should make it all into one long array. Oh, I put LST here. I got confused. Do that again. There we go. Now all our elements are in one array. And the reason I wanted to do that is because it'd be a lot easier to do when I want to make a set of them. So let's see. So we're gonna make a new set prime factorization flat. And let's console.log that out to see that that's working well. Perfect. 2, 3, 5. That's exactly what we wanted. So that was step 1 and step 2 of what we said our game plan was. So our last step is really to just check these things against our integers up here and then start doing all the adding up and such. So when we're checking one array versus another array, you're inevitably going to have a for loop within a for loop. So let's just get to writing that. Comment here. All right, let's bring it on home. So we're going to have a result here that's going to hold our final result, and we're just going to build upon it. So it's going to be an array of numbers. And then so we're just going to say we're going to use a for loop here. We can use a there's the let of loop and let in loop. I always get them confused because one's for objects, one's for arrays. What I'm going to do is I'm going to just use of here, and then I'm going to make sure that that's correct. Let prime of prime factorization set. Real quick, I'm just going to console log prime just to make sure that this is actually what I want to get. So this should be 235, perfect. Okay. And then so within our result, we're going to have individual, I'll call them entries. So our entries are going to be, so the first number is going to be our prime number. And then the second one, we can just set this equal to 0 for now and then just sum up as we go. And then so we're checking our primes, and now we got to check against our list. Again, they used I in the literature, so I'm just going to use that. And then we're going to want to say, so if that integer divided by our prime gives us 0 as a remainder, we are going to take the second part of our array here. So this is index 0, this is index 1, and we're going to add to it that integer. Yeah, that should be correct. And then after this whole loop is done, we should just put that whole entry into our result here. So let's test that out. Actually, so this should give us the result, like our actual result. So I'm actually just going to put result here as a return. And now I'm going to hit test and see what happens. Okay, cool. So we got something, but we didn't get quite the correct thing. So what just happened here? So it said 3, 5, 7, 2 to deeply equal 2, 3, 5, 7. So it's saying that it wants this, it's expecting this array to equal this array, but they don't match up. And it looks like the difference is, for some reason, ours goes 3, 5, 7, 2, and theirs goes 2, 5, 3, 5, or 2, 3, 5, 7. So it looks like we never sorted our primes, which they did say they wanted a list to be sorted. So I need to sort this thing before I actually start doing all this manipulation. So I could start sorting it in a bunch of different places. I think the easiest time would be like right after we flatten it. So I'm just going to add a dot sort here. I'm just going to hit test here. Let's see what we get now. Hey, look, we passed the test. That's cool. But that doesn't mean we passed the whole kata. So to pass the whole kata, we have to hit this attempt button, and we're actually going to go through. They're going to also throw some random tests, like randomly generated tests, to make sure we're not just hard coding an answer. And as you can see, we failed. So what went wrong here? So we have 2 tests that went wrong, but let's just look at the top one real quick. So it looks like we have negative 45 here, which that's probably the problem, because I don't think that negative 45 is a prime number. 2, 3, 5, 7, and then they have 2, 3, 5, 7. Okay, so it thinks that -45 is prime here, and that's probably because our code here doesn't handle negative numbers. So there shouldn't be any difference in finding a factor of a negative number from its like positive version of it. So I think that we could just say, let's just take that number and flip its value. So let's just get the absolute value of that number. So if it's -45, we'll just make it +45 and then do all our checks as normal, and then we should be good. So let's just try that. Okay, we didn't pass, but we're getting a different result here, and it looks like, so now it looks like here is we're giving us -5. Interesting. So if -5 is put into our get factor function, it's going to put that out as a prime factor. But I don't think that's correct, because I don't think negative numbers can technically be prime. Yeah, so since the only difference between both arrays is that one entry, I'm just going to try to filter out negative numbers. So why don't I just do that? So I should have, let's see, let me console.log my prime factorization flat here. I think that's where I'll have that negative number. So you can see this is the first test, this is the second test, this is the third test. Yeah, and I have this one -5 here. So I think I just want to, do I want to filter it, or do I just want to tell it that that's a +5? Let's just try to filter it first. So I'm going to do a dot filter. So with the filter function, you have to return something that's either true or false. And if it returns true, it's going to keep it in your array. And if it returns false, it's just going to throw it out. So I'm just going to say, if I is greater than 0. If it's greater than 0, keep it, otherwise throw it out. Let's hit attempt and see what we get. Okay, so we still didn't pass the kata, but we're failing on a new test. So that's good, actually. That means that our code managed to pass an earlier test, but there's a specific use case that we missed here. So we're getting closer. So where did we go wrong here? So it looks like once again our array isn't sorted, because we have 107, then 11, then 17, then 2. And it was at this point I realized that, because this looks like it's sorting almost alphabetically instead of by like its numeric value. And it turns out that if you Google the sort function for JavaScript, it'll tell you right here that this function can take in a comparison function. And it says right here that if omitted, the array elements are converted to strings and sorted according to each character's Unicode point value. So in other words, if you don't give the sort function a compare function, it's just going to sort them in like alphabetical order instead of numerical order. So it gives you example compare functions here, but basically we're just going to want to copy this function right here. So I'm just going to do that. So I need to fix my sort so that it takes in. So the way this function works is it compares two elements within your array, and then depending on what the result is, it's going to decide which one should go in front of the other. So I'll name them I1 and I2, and I'll just say I1 minus I2, and then let's just hit attempt again. Okay, so now we're failing somewhere else, which again I think is good. So what are we missing now? 2, 3, 5, 23, 53 equal to 2, 3, 5, 23, 31, 53, 61. What's going on? All of a sudden, we have less prime numbers in the results. Why is that? So if I go back over here in console.log our prime factorization, let me hit attempt here. So it can take a while to like learn how to read the output here, but what I'm reading, so I know that these are all individual tests. Here, I'll make it a little easier by just saying like, yeah, I'll use little lines here to divide the test up to make it easier to read. So first, second, third, fourth test, fifth test, and here we have, when we get to our prime factorization, we have we have this -61 here, and then this -700 or -31, -700 or 7,451, which are all primes that we're missing that they have here. So earlier I said that I wanted to try to filter out any of those negative primes, but it turns out that what they're doing is they're just making them positive. So instead of a dot filter here, let me try to do a dot map. And what I'm going to do is I'm going to take each element and I'm just going to return, again, the absolute value of that element. So this should just flip all those negatives to positives, and I hit attempt here. Oh, it still didn't work. Why is that? I'm getting again 5, 2, 3, 7. I probably need to add my sort after my map here, so let me just do that. That makes sense. And there we go. So we hit attempt and we're all done. We have passed to Kata. We can now hit submit. But at this point is I like to look over my code and see if there's anything that we could just improve, or not necessarily improve, but make it look more impressive for when other people are looking at. And the biggest thing for me here is like I can make all this again one line. So I'm just gonna do that real quick. So I'm gonna delete these console logs, and then I'm going to say that this is going to return my set. It's all gonna be on one line. So what I'm doing is I'm taking this whole thing, let me delete here. The whole section where I flatten it, I'm just going to add that on top. And then I'm gonna take that whole result and make a new set out of it, and boom. Just like that, that's one line. Then we can just make this prime factorization, and then let's hit attempt again to make sure it still works. Yes. Is there anything else I can do? Probably, but I think this is good enough. I'm just gonna turn this in. So I'm just gonna hit submit. All right, so the kata's done. At the end of it, you can go looking through other people's solutions to see what they all did or how they did it. And hopefully this gave you an idea of what these katas are like and what they can be. Well, anyways, that's all I got. Thank you guys for watching, and adios.